Hey everyone, in this video we're going to go over our Unit 1, it's our Introduction to Chemistry, and we're going to focus just on Section 1, which is just Chemistry and Matter. So here we go. This is the overview of everything we'll be going over. So notice that there's three different sections. We have Chemistry and Matter. Later on we'll be going on Scientific Method, and we'll finish it off with Lab Safety. We have a few labs along the way, and a project down here for our everyday chemistry. So let's go ahead and start with the vocabulary. All right, so make sure that you take all these different terms and you define them in your science notebook. Make sure you save it in the section for vocabulary, and I'll be checking those during our notebook checks. And section 1, it is very simple. There's only three terms on section 1, so make sure that you define science, chemistry, and mass. And that's all we need to say on vocabulary so far. Let's go ahead and jump right into what is chemistry. And so we know that chemistry is a branch of science, but that doesn't really tell us much about what's going on, right? So first we have to define what is science. We may need a little reminder on this. So remember that science, it tries to explain the natural world through evidence. So we conduct experiments, we collect information, and we use that as evidence to explain the events that happen around us. That's usually done through scientific inquiry, and remember that it's a planned and deliberate investigation. We have to set out to find out all these things. And finally, we can put all that information together and make models to help us explain things that we learn. So if you take this, for example, this is a water molecule, and I know it looks just like a very cute drawing. It's very round and very colorful, but there's actually a mountain of information in this small visual right here. And so I won't get into the details of it now, but as we go through our future chapters, as we learn more about chemistry and all the different elements, we'll begin to uncover a lot of the information that is hidden in this very simple drawing. So now let's get more into chemistry. So what is chemistry? So here are two ways you can think of it. Is that chemistry is the study of matter, and a lot of times it's even called the central science. So let's look at each of those and start with matter. Let's just talk about matter for now. Listen, you need to know that every physical object in the universe, anything that you have ever touched or felt, has been made of matter. So the stars and the sun, the planets that you see up in the sky, those are all made of matter. And even the food that you ate for lunch and dinner yesterday, those are all made of matter, and everything in your body is made of matter too. Now, chemistry is in general just the study of matter and the changes and interactions that it can go through. So now if you think of just everything, every physical object you have ever known is made of matter. And so that is all basically just chemistry. It's a very broad subject, it's very big, and it can be a lot to keep track of, but we can break it down into very simple principles that help us understand the world around us. The thing about matter is that it is measured by mass. This is how we can keep track of matter and say how much of it there is. The instrument that we use to measure it is most commonly a scale. So you may have used these before. So you can see on the scale, it's just got a plate. There's some weights set on it, and we see a reading on here for how much it weighs. So you can see that all of those cylinders weigh 226 grams in total. So you may have used scales before. Maybe at the grocery store you weigh out your produce, your fruits, or maybe use a bathroom scale to know what your weight is. These are all ways that we use to say how much matter an object has. And something that's important to clear up right now is that matter and weight are not the same, even though we use a scale to measure both. All right, so on a very technical level, they're not the same and they're slightly different from each other. So matter just measures how much stuff there is in an object, whereas weight measures how heavy it is, or in physics terms, you could say how much force it takes to lift it. So if we look at this example over here of an astronaut standing in two places, one on Earth, one on the moon, not drawn to scale by the way, but we can see it's the same astronaut, and she has a mass of 120 kilograms, right? So that's how much stuff she is made of. Altogether, it is 120 kilograms of stuff. So you can see that she has a mass of 120 kilograms on Earth and a mass of 120 kilograms on the moon, but notice that her weight is different in each of those places. So on Earth, she will weigh 1,200 newtons, or you could say that it would take 1,200 newtons of force to lift her, whereas on the moon, it would only take 200 newtons of force to move her. So now you can see that she has gotten lighter just by being in a different place, the Earth versus the moon, but the amount of mass that she weighs hasn't changed. So she is lighter, it takes less force to lift her on the moon, but she hasn't changed how much stuff she is made of. Now, we talk about matter just in general, it's what everything in the universe is made of, but we also need to be aware that there are different types of matter. And at this point, it doesn't matter too much what those different types are because we'll be learning more about those later on. But we should know that uh, you know, when you can take something that's complicated, say your car, you know that your car is made of a lot of different things. It's got doors, it has windows, it has a steering wheel, it has wheels, all of that. So you consider this large unit to be a car, but there's still these smaller parts that build up to a car, right? So you can always go smaller and smaller. You can think of the engine and all the smaller pieces of the engine that work together, right? So we can always go smaller and smaller, go more basic in terms of our composition of any item. But there's a limit that we reach, and so that limit is actually the atoms. Now, you might have seen this picture of an atom before. This has a nucleus, and it has the orbitals with electrons whizzing around. Um, you've seen the picture, and maybe you've heard the term of atoms being tossed around. But for now, we just need to know that they're the basic building blocks of matter. This is small for the pieces that we can get. We'll be learning more about atoms when we get into our unit 3. We'll talk about their composition and the different types of atoms that we can have. But for now, just know that atoms are the basic building blocks. And they are so tiny that we can't even see them with a microscope, right? So we use microscopes to see the very, very small, but even those very, very small things are still made of atoms. We can't see our atoms with microscopes, so we say that they are submicroscopic. They're smaller than we can see with a microscope. Now, the central science, right? So as we said before, is that everything is made of matter, and chemistry is the study of matter. So for all that, chemistry keeps track of anything that is physical, anything made of matter, and it forms the basis for a lot of our physical sciences. So if you can think of it in terms of a pyramid, we know that math is the most basic science. Everything is built upon math. We use math to explain the forces of physics. Now, these forces of physics tell us how atoms can behave, how they can combine together and form matter. This is where we come into with chemistry. Now, when we get to chemistry, we're talking about every physical object in the universe, and from that we can build up bigger and more specific applications of it. So something like biology, chemistry explains all the reactions, all the molecules that go into a living organism that creates biology, and we can use biology to more specifically talk about medicine, how all these different organisms, how they might respond, or if they get sick, how we can heal them and how we can fix them. All right, so you can see that all these sciences, they're building up of each other, right? They have some sort of base that they then become more specific. And so you can look at this cartoon here too, which goes along that same idea. So if we start here on the left, we have sociology. We can see that sociology is a very specific application of psychology. Now, we couldn't have psychology if we didn't have living organisms with a conscience, right? So really, psychology is just a specific use of biology. Well, we can't have biology without chemical reactions and having a metabolism and then building cells, right? So all that is explained away by chemistry, the study of matter, right? Well, if everything that has to do with chemistry is matter, matter is really just defined by the forces in physics. So we can see that again, physics forms the basis of chemistry, and we know that physics can be all explained by math. All right, so it's because of this principle that chemistry can study anything that is made of matter. We can use that principle to connect a lot of different fields of science. Just talking about chemistry and the study of matter, the study of pretty much everything, it's a very broad topic. There's a lot that goes into it. So chemistry can be classified into all these different focuses, right? So we can have something like organic chemistry, where we can have a periodic table of the elements. We see every type of atom that we can have, but organic chemistry really just focuses on a single element. It focuses only on carbon and what it can do. So this is just one piece of, let's see, over 100 different types of matter that we can have. So again, organic chemistry is a very specific field of chemistry. Then we get into the inorganic chemistry, which just means not organic. So literally, if organic chemistry focuses on carbon, inorganic will focus on everything else. And more specifically, inorganic does a lot of work with metals and minerals. So we can get into the physical chemistry, which in this case, we don't really care what the atoms are. We don't care what elements they are, but we just talk about how they interact together in a physical way, right? So physical chemistry might explain something about reaction rates, how molecules fit together. Analytical chemistry breaks everything down into the specific parts that they're made of. So in analytical chemistry, you might take a molecule made of all different atoms, and you want to know what each of those atoms are. That's what analytical chemistry will take care of, and it's very useful for the use in forensics. Now we get into biochemistry, which we don't care so much about the elements, but we're looking into bigger molecules. These are the biological molecules, so things like proteins and lipids, fats, and carbohydrates. Those things that you think of as the food that you eat. These are all part of biochemistry. Right, we can also talk about the environment and all the chemicals that are present. You can hear about this a lot in the news. How maybe there was a chemical spill that went into a river and it poisoned a lot of the animal life around there. Well, we're talking about all these different chemicals having an effect on the environment. And then we get into industrial chemistry, which is pretty much anything that has been made in a factory, something that is manufactured, or that it can be sold as a product, usually comes through industrial chemistry. So if you can think of something like Velcro, it was a product of industrial chemistry, and it's used in a lot of our products to hold things together. They're fasteners, and they hold different pieces together. We can get into the thermochemistry. So if you recognize the root word thermo, kind of like a thermos, or if you can think of a thermal blanket, that usually means heat. So really, thermochemistry is just talking about the heat of all different sorts of matter.